In this video, we're trying to find the value of the limit using just a table of values, the table of x and y values. As you can see, we're asked to find here the limit of the y function as x approaches the target value of -2. So we want to know what happens to the function in terms of the limit when x approaches the -2. And as you can see, this is an overall limit. It doesn't tell you what the right and left-sided limit is, so we have to confirm that both sided limits, the right side and the left-sided limits, agree. They have the same value so that the overall limit may exist. Otherwise, it will not exist. If one of the sides does not exist in terms of the limit, then the overall limit does not exist. All right. So the right side and the left-sided limits must exist and they must agree. Okay. So now, as you can see, we need to find the target value in this list of x values. The target value is -2. So let's find -2. -2 will be between these two values because -2.0001 is smaller than -2 and -1.9999 is bigger than -2, right? So you want to put the line here because that will be the -2 value for the x. Now let's see. So I was telling you about the right-sided limit and the left-sided limit. So let's see what happens when you approach the x value, the target x value of -2 from the right side. Now from the right side basically means that you're going to start with the higher values than -2, and as you approach you will see what happens to the y values. So higher value, here the highest value is -1. So we're going to approach here to the target value of -2 and we're going to study the behavior. As you see, the y increases, right? It's 4.5, then it's 100, then it's 120,000. So it looks like it will increase infinitely, right? It will just rise infinitely. There's no limit here. So you can see, you can basically mark this as increasing y values, all right? Increasing y values. Now, what about the other side? So the right-sided limit seems to be infinity, right? So as you approach from the right to the target value of the x, -2, the y seems to increase infinitely, right? So we say that the limit is infinity. However, the left-sided limit, you have to take in the smallest value of the x and approach the target value of -2, right? So we're going to start here, -2.01, -2.001, and then the yellow line is there. Now let's see what happens to the y values as we approach from the left side to the target value of -2. We start with -8.5, then it gets really, really small. You see the value gets to be -130,000. So it looks like it's decreasing infinitely, right? It's decreasing. So we can say decreasing. So if it's decreasing, then it's safe to assume that the limit is -infinity here. Now, take a look at this. Infinity and -infinity is not the same thing. We said that the limits must exist and they also must agree. Even though the limits exist here, right? It's infinity and -infinity, they don't agree because these are not the same. So as a result, the answer to this would be does not exist because we have to have the same thing. We have to have the same limit values or the same sign, whatever it is, the value or infinity. We have to have them agree. They don't agree here, so it does not exist. So as a result, be sure you understand it would be choice C if you were given a multiple choice here. Notice the other choices are wrong for several reasons here. -130,000 is not the limit value. It's not even a one-sided limit value because this is not a target value of -2. It's -2.0001. And for the same reason, 120,000 would be wrong because this is the value of the x value at -1.9999, right? It's not the limit value. And -2 obviously is not the y value, it's the target x value, okay? So does not exist is the answer to this part. Now the second part is similar. Here we have to find the overall limit of the y function as x approaches 6. So 6 will be the target value. So let's locate this value. It's going to be right between these two. 5.999 is smaller than 6, and 6.001 is bigger than 6, right? So it has to be right there. Okay, so now let's see. And just in case, I want to point out, so this is y is equal to 6. And here we had y was equal to -2. Oh, not y, sorry, why am I writing y? This is the x value, x is equal to 6. This is the x value of -2. Okay, so now that we have that, let's see what happens to the left-sided limit first, what the left side limit value of the y is. So we start from smaller values and we approach to the target value of x is equal to 6, right? So we start from the smaller values, we go here. What happens to the y? The y seems to be increasing, right? Increasing. And it's not just increasing, it's increasing to the value of 5 pretty much, right? Because after that, the y value is over 5. So it looks like it's approaching 5. So let's see, we can say it increasing to 5. Now, on the other hand, the right-sided limit, as the x value gets smaller, starting from the larger one, 6.5, 6.01, 6.0001, the x values seem to decrease, right? It's getting smaller, 5.8, 5.6, 5.4, 5.5. So it's getting smaller, so we can say decreasing to 5, right? Because as you can see, the line x is equal to 6 is right between 4.5 and 5.4. So it's safe to assume that the limit value in both cases, the right-sided limit and the left-sided limits, are both 5, because this is the target value of x is equal to 6. This is the line that we drew, right? So 5 is pretty much between these two values. So it's safe to assume that these two limits, the left side and the right side limits, are both equal to 5. When they're both the same, they're both equal to 5, the overall limit will be equal to 5. In this case, the limit exists and it's equal to 5. So the answer choice would be this one. Now, of course, 0 would be wrong because 0 is outside the range of values that you see here, let alone being at the x target value of 6. 6 is going to be the x target value, and the -1, of course, is also outside the range, just like the 0 is. So I hope this was helpful. Thanks for watching. See you in the next video.